Hello, this is Joyce from Teaching Growth, and this is the second trigonometry short that I'm doing, and this one's on cosine. If you've seen my sine video, then some of the concepts will probably be familiar, and I guess we'll get into it. So, of course, when we're talking about trig and cosine together, we're talking about triangles, specifically right triangles in this case. So I'm going to draw our sample right triangle right here. And just a quick reminder, a right triangle is simply any triangle that has a 90-degree angle contained within it. Doesn't have to be bottom left corner, can be anywhere. Now, in order to define cosine, of course, it depends on the perspective that you're looking at it from. So we chose this bottom angle in our last video, so I see no reason why we shouldn't keep choosing it. So we're going to go with this angle once again. Now, when we talk about hypotenuse, opposite, and adjacent, of course, hypotenuse is still going to be the same. It's going to be the longest leg. It's going to be the slanted or diagonal leg. However, when it gets to opposite and adjacent, it's once again still the same. It's adjacent and opposite. And you might be wondering, well, how is cosine any different from sine then? Well, it doesn't involve the definitions of the legs and angles within a triangle. Actually, the definition of cosine relies more on the relationship between two different legs. If you remember in mnemonics, so katoa, when we went over it meant that sine of theta, or any angle, is the ratio between opposite and hypotenuse. But when we're talking about cosine, or the ka, it means that the cosine of the angle is actually equal to the ratio between the adjacent and hypotenuse. So different numerator in this case and different relationship. So much like sine, this equation can be rearranged to solve for h or a. So we can solve for a equals to cosine theta times hypotenuse, or the hypotenuse equals to the adjacent over cosine of theta. And just like sine, this also has an inverse, and it's also notated the same. Cosine to the negative first power of theta is going to be the way you write inverse, or you can write it also as arc cosine of theta. And once again, this should not be confused. It definitely is not the same as 1 over cosine, even though it's tempting to think of it that way since it's to the negative first power. It's just the way the notation works. It's a bit confusing, I know, but bear with me. Now, just like with sine, this can be used to solve for the angle that you're looking for. So say you're given the adjacent and the hypotenuse legs. So we have our ka, so cosine of an angle equals to adjacent over hypotenuse. Once we take the inverse cosine of both this side and this side, remember inverse and normal functions will cancel out, leaving us theta on this side, and the inverse cosine will still remain on this side. So if we want to solve for angle, we'd take our inverse cosine of our adjacent over the hypotenuse. Now, something I didn't mention in our last video, most calculators will actually do these inverse functions for you. It'll probably be a modifier key you hit, and then hit sine, cosine, or tangent again, and it should give you the inverse. Just something I thought I would mention. Now, just like last video, I want to do a quick example. So the example for this time, we're going to do actually solving for an angle this time, just like what the quick example I did just now. So we have our right triangle with, our right angle and our angle theta, and we don't know what theta is. However, we're given our adjacent and our hypotenuse, so we do know those. So this one and this one. And we're told that our hypotenuse is equal to 5, and we're told that our adjacent is equal to 3. So, and they want us to solve for theta in this case. What would theta be? Well, we have our SOHCAHTOA, and ka reminds us that the cosine of the angle is equal to the ratio between the adjacent and the hypotenuse. Now we want to solve for this theta right here. So we're going to take the inverse cosine of both sides. So once you take the inverse of this side, the cosine will be canceled out, and you'll just be left with theta. And you'll have cosine inverse remaining on the other side of a over h. Now, I'm going to give you some time to plug this into the calculator as well as I do it. So this will be 3 over 5. And the correct answer should be 53.1 degrees. If you do. And I think I mentioned this before, but some calculators may not have it. Most calculators do have the option to give you the inverse function, but if you don't, I recommend using the online website Desmos. It's a free calculator that you can use online, and it has graphing abilities, and it's really useful all around. And I hope you enjoyed the video. Be sure to check out my sine video, which I made earlier, and I'll also be making a tangent video in the future. And if you feel like you need any more help, more explanations, be sure to check out our YouTube channel or visit our website or center directly, because on our YouTube channel, we'll be posting some videos explaining more math concepts, more science concepts, and in our center, we offer one-on-one tutoring directly.